Let's summarize the conclusion that we came to in the last video. If we have a parabola that has an equation in the form x squared equals 4py, then it is going to be a parabola with vertex at the origin. The focus will be at the point 0, p. The directrix will be the line y equals the opposite of p. And we actually have two possibilities. If p is a positive number, it's a parabola opening upward, and the focal point is above the x-axis. But if p is negative, that gives us a focal point that's below the x-axis and a parabola that opens downward. So this could end up having a negative value for p, and it still ends up working, it's just opening in another direction. So let's take a look at a quick problem. Find the equation of the parabola with vertex 0, 0 and focus 0, 2. If the focus is at 0, 2 and the vertex is at the origin, that tells us the value of p is equal to 2. And when we substitute that into the equation, we get x squared equals 4 times p, which is 2, times y, and 4 times 2 is 8. So we get x squared equals 8y. Or, if we want to solve for y, we can divide both sides by 8, and we get y equals x squared over 8. Both of these are perfectly valid answers, and we might prefer one or the other for a particular reason if we're doing an application problem, but either one of these is perfectly fine for what we have now. In this example, we have an equation in the form x squared equals 4py, but what I want to talk about now is what happens if we switch x and y, and we have something in the form y squared equals 4px. What would that graph look like? Now, we have switched x and y before in a previous topic. When we're looking at inverses of functions, we can switch the x and the y to figure out what the inverse of the function is. Now, we're not actually going to be looking at inverses because we know that a function like this is not one-to-one. It fails the horizontal line test, so it doesn't actually have an inverse. So we're not going to go down that route, but we do know that when we switch x and y, we end up reflecting things across the line y equals x. And if we had a parabola opening upward and we reflected it across the line y equals x, what we would end up getting is a parabola that opens to the right. And so if we switch the values of x and y, and we end up with something in the form y squared equals 4p times x, we're going to have a parabola that's opening to the right or to the left, depending on whether the value of p is positive or negative. And then in that case, our directrix is a vertical line, and we end up with a parabola like this. In this situation, it would be a parabola that has vertex at the origin. The focus will be at the point p, 0. The directrix will be the vertical line, x equals the opposite of p, and it will open to the right if p is positive, and to the left if p is negative. Again, let's take a look at an example, but this time let's look at one that opens horizontally. A parabola has equation 10x plus y squared equals 0. Find its focus and directrix. Now, because it's y that's squared here, we know that this is going to be one that opens horizontally. So what we need to do is isolate the y squared so we can write this in the right format. To do that, we subtract 10x from both sides. This gives us y squared equals negative 10x. And we want to write this in the form 4 times p times x on the right. And so if we factor a 4 out of negative 10, we get 4 times negative 2.5 times x. So in this case, P equals negative 2.5. So we know that the focus is at the point P comma 0. So in this case, negative 2.5 comma 0. And the directrix has equation x equals the opposite of P. Well, in this case, because P is a negative quantity, the opposite of that will be positive, and so we get x equals 2.5. And so we have the focus and the directrix of the parabola, which is exactly what we were asked for. Now, one final thing, and we're going to look at this a little bit more in the last video of this section. Knowing the focus and the directrix of a parabola isn't too much help in drawing the graph of the parabola, because even if we know these two quantities, we don't know how wide the parabola will open just from those pieces of information. We're going to have to do another calculation, and that's what we're going to focus on in the next video. This will help us know how wide the parabola opens, and it'll be an aid for us to sketch graphs of parabolas if we're looking at them in terms of the focus and the vertex and the directrix.